This is TWIS. This Week in Science, episode number 904, recorded on Wednesday, December 7th, 2022. Justin, how can you science your way out of a lying toddler? I'm Dr. Kiki, and tonight on the show, we are going to fill your heads with Chardonnay, lying toddlers, and a big ol' science feud. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer. The planet, Earth, the one we are living on, is in trouble. The moment in which we can do something about it is now. We let a lot of nows go past without doing anything, and so we are running out of them. So this now, the today now, is really the most important one of all. So much so that the United Nations COP15 Biodiversity Conference that started today is being called the last best chance to save the planet's species from irreversible destruction. So there is still hope that a global deal to protect nature and the benefits it provides to all people will be negotiated during the conference. We just need to rely on world governments to prioritize things that there's. What do they got there? The equitable sharing of benefits from the use of nature and the safe transport, handling, and labeling of modified organisms. Oh, no, they're going to address biotech legal issues, not planet-wide sustainability, which is important. The biotech issues are extremely important. That's such a weird issue that you can't use a microbe if it was found in a foreign nation to do your research. But still, the planet is the planet. We only have one. And it's the only one we know that can support This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki.
And a good science to you too, Justin. Blair is out for the night, but we are here, as we love to be, to talk about science pretty much every week of the year. Oh, it's December already. I don't know how it got here, but somehow we are here.
Well, last month.
I know, it was November. Yeah,
and before that.
It is October. I know.
It keeps going. It doesn't pause. I keep waiting for
the pause button.
Pause.
Yeah, no, there's no pause button. It keeps going. And so here we are in December. And yeah, I just want to say happy Twissember.
Yeah. This is always an exciting month because we're gonna have at some point, I think still in December, we have the top 11 stories of this past year. Yeah. Boy, and it's been
what year is it? 2019.
It's 22. You're still paused. We got to unpause Kiki.
Right. Okay.
And then at some point, either by the end of this month or maybe the beginning of the next month, we'll have our prediction show.
Yes.
Where we're going to check how the predictions we made last year about this year's science and make new predictions for the future.
The scientific future. Yeah, so there are some fun shows that are coming your way and our way because we enjoy doing these shows every year. And this is another week full of great science news. And I have brought stories about, yes, a science feud. Yes, there is a debate happening in the Paleo community. And Justin, you're going to love this story. We also have I brought the lying toddlers. That's what I do. I come to parties. I bring the lying toddlers. And I brought a cold nose, some animal sounds, and some concerns about Neuralink. What did you bring?
I got really old DNA,
Yes.
how to avoid autumn children, a new animal segment, idols versus owl dolls, and just good news, Chardonnay edition.
Oh, I love Chardonnay.
Hopefully my
Let's
internet
get
can
some.
recover from opening a Google document. I don't know why it becomes a problem.
We will see, as we will also see what is going on with all these scientific stories as we jump into the show. I want to remind you all that even though Blair's not here, we're going to still talk about some animal stuff. That's going to happen. And if you have not yet subscribed to the TWIS podcast, you can find us most places podcasts are found. We are known as This Week in Science. You can find us also by looking for TWIS. And we stream weekly, 8 p.m. Pacific time on YouTube, Facebook, and Twitch. We are TWIS Science on Twitch, Twitter, and Instagram. And if this is just a lot, go to twis.org. That's our website where you can find all sorts of fabulous things, like the link to purchase our 2023 Blair's Animal Corner TWIS calendar, which Blair did some amazing work on to create some incredible Lego animals. It's all Lego based. It's really
so
great.
rad.
Yeah, and you can purchase through the Zazzle link, which will get you a nice printed calendar, or you can also purchase through a PayPal link that will get you a downloadable PDF so you can print it as you would like. But now it's time for This Week in Science. What do we have? I want to start with a little science battle. You ready?
Yeah. What is this? You built the controversy teaser. Now I know what it is.
I know, this controversy. So we have talked on this program about the paleontological discovery at a site known as the TWIS site that is here in North America that has evidence in the form of little, not crystalline, but spherules that were found in fish and fossilized organisms and the layers of sediment that time it to the impact at the Yucatan crater of the asteroid that killed all the dinosaurs about 65 million years ago or so, creating huge tsunamis that pulsed up through the river valleys of North America and really show the impact of how far-reaching that impact actually was. Killed the dinosaurs, but what else happened? Okay, so we know that there was a researcher who, Robert De Palma, who published his research on this subject. There was another researcher named Melanie During who, in June 2021, submitted a manuscript to Nature. And she was pretty excited because she was working at that same paleontological site, which, by the way, Robert De Palma has the lease on to do the work in. But she was a graduate student. She's doing the work. And she was like, oh, I found some cool things. She got De Palma to send her fossils that she dug up. And she did a lot of work that really solidified those spherules that could be used to carbon date the impact and what had actually happened. So they were working together, During and De Palma. They were working together. They were at the site at the same time. De Palma actually sent her fossils. They were all doing their stuff together. During put him as a second author on her paper that was published in Nature in February. And she discovered in December 2021, while her paper was still being reviewed, peer-reviewed, her collaborator, De Palma, published his own paper that did not use, she wasn't included on, used a completely separate data set, and they are saying that De Palma made his data up.
What?
Yeah. So this is reported in Science.
Who's that? Oh my.
And the Melanie During, she has a Twitter thread that she talks about this a bit on. This is reported by Michael Price on the science.org news website. But the thing is, he published basically the same conclusions that During had come to, but without putting her on the paper, using his own data that nobody can replicate, that nobody can know whether or not it's accurate because he has been unable to produce that data set. People have asked for the data set and he isn't giving it to anybody. And so this
is very, very sounds like he Francis cricked her.
That's kind of what it seems like is going on. Yeah.
Like, you've come to a final solution. Well, why don't I write a paper that just points out the final solution, and then it's like, I'll get to fill in the details later. Yeah, because that's literally how they ended their first paper on DNA. By the way, we understand ramifications of what we've put in this paper, and we'll provide more definitive details on it later. That's how they finished their paper. Here's our conclusion. We'll give you data and fill in stuff some other point further down the road.
Yeah. So in this Science article, it says that the data that would be the data that De Palma would be giving to everyone to support his analyses, he says the raw data are missing because the scientist who ran the analyses died before the paper was published. And so nobody's been able to get the data out of this deceased person's laboratory.
Okay. Now look. As long as he did name them on the paper,
right?
Cited them that work. So because that's a huge thing. Raw data can sometimes be pretty massive. Sometimes take up a lot of space. It sits on a computer or a server somewhere. It's not the output that you generally put into a paper. It's not that's the analysis is all done in the box, right?
Yeah,
if somebody who owns that box is dead, it can be impossible, maybe even really difficult to then get into that electronic device, get the rights to it. You got an institution, and then you got an individual, you got passwords, you got encryption stuff, all that sort of nonsense involved. That's possible.
Yeah.
At least.
So, what I think is very interesting here is that in science, getting the scoop, being the one to publish first is often, that is so much of the scientific endeavor. Competition we don't talk about it a lot on this show, but the competition within science is to be the first to publish something there's huge pressure there. And so there's a game being played here that we might not know. We don't know all the information on. What we do know is that De Palma did release a lot of the information ahead of publication, that there was a media circus around his findings, that there's even a documentary that has been published related to the findings that he and also, what During published about and other researchers. But there's a lot that hinges on this, and it's fascinating to watch this coming out in real time, and to see a young female scientist actually putting her foot down and trying to get some credit, right? Saying, no, I did this work. This is my stuff. This is what I did. And, so
is there etiquette involved, though? Because you're saying, he's got the lease.
There is etiquette. She put him as second author on... She put him as second author on her paper, and he left her off.
Okay, yeah, that doesn't sound right. But then again, the way you presented it initially is he had the lease to do the research on this land. This sounded like his project.
Oh, yeah, he's got the lease.
And he let other researchers jump in.
Yep.
So is there any kind of etiquette where it's like, all right, this is your project. I've got a paper that is now ready to go. But since this is your thing that you brought everybody else onto, do we wait for you to publish? Do we confer with you first? Like, I don't know how that's all supposed to work. But I can tell you if it is fake data.
Yeah, and that is the concern. So During has said that she's noticed irregularities in the figures. There's concerns that the authors are publishing their raw data, and they're so people
they're dead.
People are looking into it. I mean, the story still stands because During has published her data, which she insists is correct, and she can publish her raw data. She's got it supporting her. So anyway. It's a scientific...
because
it's a feud.
She didn't collaborate with dead people.
That's right.
That's a very difficult situation. It's a very difficult situation to parse out from the outside. However, if she contributed to the findings that are in the paper that she was left off of,
yes.
Then yes, you should absolutely cast this individual out into the wilderness, banished from society. If, on the other hand, if the perspective is this was his project and he let other people jump in and do research in that space that he had carved out, as long as they didn't interfere with his thing, then it's a different story.
Yeah, so here's the question. Is it he was doing his own research and doing his own thing and let other people use the ground that he was leasing, that area? Or is it that, she shared her findings with him, tried to get him to be on, to work with her, and he refused, and then went on without her, using her information.
Jealous that his project, where he found nothing of interest, somebody else has made a major discovery, and well, it should be mine. I got the land lease. I filled out the grant paperwork or whatever it was, and therefore everything's mine. Right? Yeah. Then that guy is a jerk.
Yeah. So what the bottom line is? This is the stuff that has been found at the TWIS site does have data supporting it. We do have data that supports the timeliness. We do have data that supports how this might have worked. So it's great to know that there are possibly multiple studies that are all supporting the interpretation of what happened and what De Palma has been publicizing through the media.
Or one story that has data supporting, and another one that claims to. Yeah. Because actually, and this is an interesting thing that's sort of sideways, but it's actually a problem I have with a lot of early psychology experiments. There's a trend of early psychology experiments when a big study is publicized and a lot of people. The marshmallow test is a perfect example.
Yes.
The marshmallow test got a lot of attention right away, and subsequently researchers did their own version of it, different, and got like the exact same result.
Right.
Something that in psychology is insanely difficult to replicate to begin with. But when there's a very popular study, there's a bunch of researchers who, this is especially old, and I'm sure it goes on still today, but this is the specific cases, one of the specific cases. There's a lot of replication that happens that's very similar to the point where it becomes suspect.
No, I mean, there's the other side of it, which is the, actually in psychology, the effort to replicate psychology studies. And there has been a very big effort to actually go through these big psychology studies that seem to have these amazing results and replicate them and see if they can get the same results.
Yeah.
And very often they're not able to.
It's a
so
coin
replication,
flip.
the point is, replication is important.
It is.
Collaboration is important. Science to this, science itself as an institution is competitive, and I've known other people to be scooped on their science, and and careers change as a result of that. Who was the first? Who was the second? But it's interesting to see this come out now, and to see this feud, and we will let everybody know where it goes. Will there be more replications? Will the data come out? Will De Palma find the data? Will he not? What's going to happen? We don't know. But I think it's a very interesting case study of how science sometimes happens in a way that isn't all nice and shiny and in the laboratory and findings that we like to pretend that it is very often. But let's go back in time. You like archaeological stuff. Tell me a story, Justin.
Yeah, so once upon a time, a young PhD candidate was looking out his window, and he saw a dog take a dump on the sidewalk. And he thought to himself, wow, I bet that the DNA of that dog is going to be in the surrounding soil for the next 1,000 years. And this PhD candidate brought it up to his advisor, PhD advisor at the university there, at the science university he was going at. And the advisor said, "That's the stupidest idea I've ever heard." Well, now that candidate got his PhD and went on to become a world-renowned scientist, Professor Eska Willerslev, who has pioneered the field of environmental DNA.
eDNA.
eDNA.
Yeah.
And has made now a record-breaking discovery. 2 million-year-old DNA has been identified. Not just identified, sequenced. Sequenced and categorized.
Wait, 2 million-year-old DNA? Like
million. At least.
That's a big deal.
It could be older. This is an important note because they used the most conservative time estimation that was available. And they got to 2 million years. It could be much older, in fact. It was identified in northern Greenland sediment. Researchers discovered these fragments. That's 1 million years. Like, we have a 1 million-year-old segment of DNA from a Siberian mammoth bone. That's the record holder. Doubled it. 2 million years old. Way back. And environmental DNA, so it's not from a creature, it's from over 100. This was made possible, but it's just incredible. But okay, so this is Professor Willerslev. Says a new chapter spanning 1 million extra years of history has finally been opened, and for the first time we can look directly at the DNA of a past ecosystem that far back in time. According to Professor Chair, who I think is the one of the other researchers on the paper, the ancient DNA samples were found buried deep in sediment that had built up over 20,000 years. The sediment was eventually preserved in ice or permafrost, and crucially not disturbed by humans for 2 million years. At first I read that and I'm like, wow, something undisturbed by humans for 2 million years. And then I was, oh, well, yeah, current modern humans weren't really
not really
around for most of that time. And we show up and the first thing we do, hey, let's go dig in that undisturbed 2 million year old bit of dirt. So
ice.
Samples were taken from something called the Kubenhauen formation, a sediment deposit 100 meters thick at the mouth of an Arctic Ocean fjord in Greenland's northernmost point. The climate, they say, there in Greenland at the time was varied between being Arctic and temperate. It was 10 to 17 degrees Celsius warmer than Greenland is today. So much warmer than now. It was 40 researchers from Denmark, UK, France, Sweden, Norway, US, and Germany working on this, looking at the DNA segments. Apparently, the process was pretty painstaking. This is 2 million year old DNA, and they needed a way to get the DNA that was hidden in clay and quartz rock and detach it from the sediment to examine it. And the question is, could they do that? And the answer was no. They could not.
Okay.
Yeah, they could not do it. And so at this lab says we failed. We tried and we tried and we tried and we tried and we failed and we failed and we failed again. And then they did some more science to it, and the answer became yes, they could, yes they did. Researchers turned to matching these DNA fragments with animals, plants, and microorganisms. And they created a map of a 2 million year old ecosystem because they got so much. This must have been sort of exciting and also a little bit tedious, because what you're doing is you're Googling within a library of known DNA, very small fragments. Yep. You would hope to have a sentence. You might have you might have a word, you might have a couple of words. You hope to really have more than that in a row. In these fragments, you might get some of that, you might not. But so what happens is you could get a conserved section of DNA. This little fragment that you're searching through the library might be a conserved fragment. It might come back with the answer plant. You might come back as like, this matches mammals.
Right.
Right. You could be, but if it's more specific segment, something that isn't as generally conserved, it works more like a keyword search. So now you're searching in the right family of animals, right? Species of animals. Maybe even get something that only occurs in Arctic hares, for instance. So some of the DNA fragments were easy to classify this way as predecessors to present-day species. Others were stuck at the genus level. Some originated from species impossible to place in the DNA libraries of any organism alive today, suggesting that only aliens from another planet could. Just kidding. It's never aliens. It never is. It never is. So,
suggesting those were lineages that died out that we that we haven't found again. Yes.
That died out, or it could be died out, absolutely, or it could be the segments. Also, the segments just might not have been able to be categorized, whether they were too small or just didn't fit into any. No, you never know what you've got in terms of that segment. What bit of the code it is. So yeah, picture began to emerge of this very different, balmy Greenland. They found DNA from trees, bushes, birds, animals, and microorganisms, reindeer, hares, lemmings, black geese, horseshoe crabs, birch and poplar trees, more than 100 plants, and mastodons.
What?
Previously not thought to roam so far off the ranges of North and Central America, they found evidence of mastodon DNA. So apparently quartz and clay in the soil played a crucial role. The charged surfaces of the minerals captured DNA and protected it from degrading enzymes and oxidizing agents. So DNA has a charge. And apparently so does the crystallized minerals, or the quartz minerals in this soil. And so I guess it would work a little bit like a static cling. It just sort of like attaches itself magnetically, I suppose, to the
electrostatically.
Yeah. And so this was all figured out by co-author Karina Sand a geochemist at University of Copenhagen. The onset of the ice ages, then, about 2.5 million years ago, helped by keeping the DNA frozen to the present day. And then such a lush, balmy ecosystem could have existed 500,000 years into the Pliocene, suggests Greenland hadn't yet fully glaciated because there's no trees in Greenland. There's not that. There's a lot of small plants, but not in any great collection. Certainly some of those animals aren't there, right? But there are muskox still there today. But the trees is really odd. So this must, so the question is, it hadn't fully gone glacier yet in Greenland, or maybe this was a warm point in an interglacial period, or the DNA might just be older than they think because of the way that they did the dating. It could be before 2.5 million years, I suppose, because that's the glaciation event coming on. But let's have this quoting here. This is a break. So this is a breakthrough when they realized they could unstick the DNA from these minerals. And Willeslav is saying, Karina's hand was instrumental in breaking the Cap-Copenhagen curse. She and colleagues learned how to liberate nearly half the DNA bound to quartz and much less of that bound in clay in 41 samples. They sequenced and extracted DNA in many short stretches and screened nearly 3 billion reads against libraries of living species. It goes on to say, DNA generally survives best in cold, dry conditions, such as though that prevailed during most of the period since the material was deposited in this fjord. But now that we have successfully extracted ancient DNA from clay and quartz, it may be possible that clay may have preserved ancient DNA in warm, humid environments in sites found in Africa. If we can begin to explore ancient DNA in clay grains from Africa, we may be able to gather groundbreaking information about the origin of many different species, perhaps even new knowledge about the first humans and their ancestors. Possibilities, says Willeslav, are endless. So, and what's really fascinating about this is that, not only did they break the record once, in the sense of getting a older DNA, 2 million year old DNA, a million years older than that mastodon bone that was previously the oldest. They did it hundreds of times. Right? Like, it's not just for one thing, it's for 100 plants and all these animals and trees.
And it's a new method because it doesn't rely on that complete isolation of the DNA from the substrate, which is something that has been basically just the foundation of genetic sequencing. So, I mean, I guess the question now is we want to make sure, the fact that they've done it hundreds of times, they've got all these different species, they've got lots of matches with different things. It seems as though they've crossed their T's, dotted their I's, done their homework, made everything work. But, the question is, even today, in looking at like COVID-19 sequencing from different places, we have contamination issues, right? So what is the potential for cross-contamination of the sample with stuff that is currently in the environment? How do we know that there's not, we need more, we need more data. We need more studies. We need replication, like we were talking about. But yeah, I mean, if this can be fossilized and preserved in a cold climate, could it be found in a warm climate where where you wouldn't normally expect to be able to find this kind of information because of degradation, because of humidity? Humidity
and heat are usually two problems. But if you've got something that's underground, not oxidized, and then you've got this static cleaning effect going on with the quartz, it gives a great possibility that this is elsewhere. And the thing that there is a mystery here that I can't quite sort. We've got a balmy They're saying balmy. They're saying it was almost an environment unlike what you see anywhere else in the world where you have the Arctic. How'd they get there? It's one thing when the North Sea freezes over, which there's still going to be the winter. It's still that far north. It's still going to have 6 months of darkness. You're surrounded. You're an island. There's water.
Yeah, swimming mastodons.
And something could walk over.
Yeah. Mastodons. They've got a built-in snorkel.
And reindeer.
I don't know.
And reindeer. So I mean, there's stuff walking over there from North America, and you usually picture that island hopping most places during a glaciation event when the sea levels are really low.
Land was kind of in different places too.
But then, if it's really cold up there, it could freeze over, so you could walk over ice. But which is it? You're saying it's too warm for the ice, but too cold for the... Oh, it's a great mystery. It's a great mystery.
It's a wonderful
It's going to be fun to
we love the mysteries.
To delve into that issue.
Yes, let's delve. Well, let's talk about the mystery of the club at the end of the ankylosaur's tail.
Oh.
Why does it have a club?
Thing back there.
Yeah, ankylosaurs.
Well, if my cartoon knowledge of dinosaurs is any indication, it's for whacking things.
For whacking things, exactly. So a researcher has been looking at the ankylosaur for years and years and years. And in this particular study, lead author Dr. Victoria Arbour, curator of paleontology at the Royal British Columbia Museum at the Royal Ontario Museum in Toronto, has been studying ankylosaurs for a very long time. And she was like, tail clubs. Some of them have them, and some of these very similar dinosaurs do not. What were the structures used for? So you think it's a big old club at the end of the tail. It's probably used for bashing. And so she was asking, okay, is it a weapon? So in 2009, she suggested in a paper, this is a weapon for bashing. But you needed evidence for that. So they did work looking at the flanks of adult fossilized ankylosaurs and found that there were all sorts of wounds that had healed. There was damage on the outside, evidence of broken and injured bony structures on the outside of these osteoderms, which, by the way, I love their name because I'm a Ghostbusters fan. They are identified as Zool crurivastator. Zool, right? Zool from Ghostbusters. And then the other words for crurivastator, Crus, Shinner Shank, and Vastator, destroyer. The destroyer of Zool, the destroyer of shins, which is a pretty awesome name to have. And, I might change my name. Anyway. The idea was, okay, is this a weapon for self-defense? Is it a weapon for, fighting against other ankylosaurs? Is it a weapon, are they fighting against T-Rexes? What's going on there? So they did a bunch of, their analyses, and they were like, look at all these ankylosaurs with their broken up bones and other things, and so anyway, evidence. The clubs at the ends of the tails of the ankylosaurs were for, not are, I mean, we just see them now, but they were for bashing other ankylosaurs. So it was like when the behavioral posturing stopped working and they fought each other. What did they have to fight with? They had the tail clubs. And so they used them against each other. The reason they know this is because there were not any comparable injuries on the other similar dinosaurs, the nodosaurs, that did not have tail clubs. So ankylosaurs were like, dude, I'm gonna fight you. And they fight each other. And the nodosaurs were like, I don't have anything to fight you with. We're not
somewhere in a grave, there is a researcher turning over an old paleontologist, well, very old now, who discovered the ankylosaur and already noticed this. And it's like, yeah, it was wordplay. Ankle, sore, get it? That's why I named it that. I discovered that 100 years ago. Oh, never mind. I'm dead now.
So from these, they did not find any evidence of bite marks or scratch marks that would have been evidence of predation.
So this wasn't the velociraptors coming and causing damage and then
exactly.
Yeah.
Yep. These were ankylosaurs going, I have a beef with you. I'm taking out your shins. I am Zool, destroyer of shins.
So it's such an oddly weighted tale in that respect. So you wonder if was this used in mating competition? Was this just accidental? Hey, look, we've developed this tail that can go like, look what I can do with my new bang. Oh, I'm sorry. Oh, and they're just apologizing to each other constantly. I didn't mean it. Didn't mean it. Just got this big whack-a-mole thing on my tail. It's way back there. I can't even see it when I turn around. I don't know. That's pretty wild.
Yeah. So the lead researcher likes to, which I'm sorry Blair's not here tonight to discuss this, but enjoys the analogy that the tail of the ankylosaurs is similar to the head of a giraffe. So male giraffes with their ossicones, their little horns at the top of their heads, will swing their necks around and smack each other with their heads and can really hurt each other and break each other's legs by using their heads and their horns as a weapon. So this is the
I had a giraffe swing at me once. It's very frightening. It's very telegraphed, too. It's not that difficult to avoid.
Here it comes.
Yeah, it's very much like that. It's like, what are you? Oh, I see what you're doing. Yeah, plenty of time. But gosh, it's powerful. So
powerful.
You want to avoid getting hit by giraffe heads or ankylosaur tails.
Or ankylosaurs and their tails, yeah. All right, let's talk about ADHD. Is that where you want to go now?
Yeah, so this is not exactly new news. We've known for decades that the youngest child in a classroom is most likely identified as having attention deficit hyperactive disorder. We've talked about it on the show plenty of times. It's all kind of came about when instead of doctors, they started having teachers do initial assessments on whether or not a child was hyperactive. And you know, the result is that a lot of kids who happened to be the youngest child in the classroom got pegged as ADHD, whether they actually were or not. Now, an extremely comprehensive study has confirmed that this is so. In the study that included all Norwegian children born between 1989 and 1998, a total of around 488,000 individuals.
Wow. Okay.
Not often you get a study that's all of a population.
Yeah.
They found that children born in November to December had an 80% higher risk of being prescribed ADHD medication compared to those just born in January, February. So I guess that means there's a pretty simple solution to ADHD. Just don't have sex in early spring. That way you avoid the autumn children problem entirely.
Right. You don't have the youngest child who is a little bit behind in the developmental aspects of
But of course, then you know what happens. Those summer kids become the youngest, and then it just continues.
It continues.
Although,
the way that we're looking at it and the way that we are defining these self-control issues and these, I guess, defining character or allowing school teachers to be the first
it's probably
the first to
not the
talk
best.
about it.
Probably
Yeah.
not the best way to go. So, according to the study lead, Christine Strand Bachman at the Norwegian University of Science and Technology, says, it looks like we're medicating the most immature children because we're comparing them to their oldest classmates who are a year older. So, obviously,
Yep.
they're going to seem different. That shouldn't be the basis for receiving an ADHD diagnosis. We have to expect that a child born in November is going to be less mature than a February child born the same year. Of course, we can't stop diagnosing ADHD and giving medicine to those who need it, but what we see here is something else. In particular, she also was studying premature children born before the 37th week of pregnancy. So then they've actually got it the worst if they're born as an autumn child, because they're prescribed medication at even higher rates, because the tendency there is they're born early in autumn, and so they're in class. They're more than a year, right? They're a year and some more months younger in essence, along the path of development than their peers. So they get a little double burden there. But yeah, she says it has everything to do with age in class. There's no seasonability link. There's no seasonality link. There's no, because of autumn children being born and having to come into the world in the winter, they become, no, it's nothing like this.
That's not,
it's
yeah,
the school
that's not the issue.
situation
Yeah.
Is the cause of excess ADHD diagnosis. One solution, she says, is that you could just wait till the following year.
Or not
enroll them.
compare children against their peers and just base what's happening on, how they're developing and whether or not they are developing and reacting to situations and working on stuff at the pace at which we consider to be quote unquote average. And, as Aaron Laura is saying, it potentially in our chat room right now over on Twitch, maybe it's lucky that younger kids get diagnosed earlier when they need it because of this. But at the same time, there is this potential aspect of overdiagnosis because you're just looking at kids who are developmentally less mature with respect to the older
higher
kids
rate.
in the class. Yeah.
80% higher rate.
So,
and then by the time they're teenagers, a lot of that's going to disappear in terms of the differentiation with who's on medications and not. But that seems like there's definitely a problem in the schools in the way. Bachman points out that studies from Denmark have shown that there is no increase use of ADHD medication among youngest pupils in class. But in Denmark, 40%, almost half of the students, half of the autumn children start school the following year. They delay.
They delay
because in Denmark, there is your first assessment before starting regular school in kindergarten, I guess. They look at the individual child and say, are they ready or are they not ready? And if they are still exhibiting a lot of those younger, immature behaviors, perhaps they might wait. But Bachman is not advocating that all autumn phones starting school, because again, that would probably just shift the problem to winter children, would then be the youngest in class. But like the Danish system, they should be individually assessed with a focus on the child's specific needs. Study also looked at other types of medication, such as depression, anxiety, psychosis, sleeping pills, and they found the same age effect for several of these drugs as well. Clearly, children born late in the year are receiving more medication compared to the older ones.
Interesting. Very interesting. This is data. Who knows?
And it was made possible too because Norway has a very centralized. It's one country, but it's like one centralized healthcare system, so they could track. They could track 500,000 kids through their medical history, which is really amazing. In their the drugs that they were assigned.
Yeah. Speaking of kids, I want to talk about some lying toddlers. Around about
I've never seen one of those.
You've never seen a lying toddler? What? Parents seem to report lying starting at about 2.5, 3 years old in kids. And the question is, what's going on with this lying? The manipulation of someone else to believe something in what you want them to believe, whether or not it's true. And so some researchers publishing in PLOS journals this week, they did an experiment in which they subjected a bunch of 2.5-year-olds to something like the marshmallow test. Not the marshmallow test, but there was a box. There's a little hole in it. And sometimes they allowed the parents to be around, and sometimes the parents weren't allowed to be around. And then they were like, don't look in the box. You don't get to look in the box. And then they'd come back later, and this is a test related to inhibitory control and whether the kids could, sit on their hands, not look in the box, listen to instruction, do what they were told. Right, what's in the box? What is in the box? And then the researchers came back and they asked the kids, did you look in the box? And a lot of the kids said, yes, even though they had not looked in the box.
Oh, interesting.
And so the question is this lying? What is going on here? And then they'd ask them, do you know what is in the box? And it was a stuffed teddy bear that was in the box.
Was not a snake. Because that's what
it was not a snake. It was not
totally
dangerous. It was, nothing or anything like that. So did you peek? And they had 35% of the kids that peeked, 65% of the kids that did not peek. But a lot of the non-peekers, actually the ones that never peeked, they said, yes, I did peek. But they didn't know what was in the box. And so the question is, why did they falsely confess to the peeking?
Well, it's sort of like when somebody asks you if you've seen a movie and you're like, oh yeah, I saw that movie, and then you realize, oh gosh, I didn't actually see that movie. I don't know anything about it. Why did I tell that lie? That's a terrible lie to tell. Now they're talking about this movie and I've never seen it. I'll just keep nodding until they change the subject. I'll never do it again.
Yes, exactly. So they did snack delay tests similar to the marshmallow trials to see, whether or not these kids had the ability to control their wants, inhibitory control. And, even the kids that were more able to wait for a snack were less likely to peek in the box and all this kind of stuff. But, what the researchers ended up taking into their conclusion was that the false confessors and even the truth tellers, maybe it was the beginning of the question that was asked. Did you? Did I? Did you do? It's yes. I understand. Did you? Yeah. And the researchers' conclusion in this study is not necessarily that these kids actually were malicious, meaning to manipulate in the lie that they told at 2.5 years of age, but more that it was a spontaneous lie rather than deliberate, because they were following the language that the adult was using. And not so much that the kids were like, wanting to lie about something.
Yeah, and it's also going to be a thing where every single child imagined looking in the box.
Right, exactly.
So in the child mind of, did you look in the box? And they're thinking like, oh yeah, like several times apparently. there might be a memory of imagining it over and over again because something has been drawing your attention to it. So, yeah, it's very interesting.
I mean, an adult comes to you and says, "Did you peek?" Yes, I did. Yes.
Supposed to? Then yes. If I wasn't supposed to, then definitely not.
Yeah, so this is more of an impulsive as opposed to a manipulatory response.
But they're fully capable of that too.
They are fully.
They're fully capable of that.
Yeah.
I've had 3 toddlers, two of which definitely made up stories to manipulate their papa.
For sure. 2.5 years of old?
Oh yeah. Oh
2.5. Okay.
Yeah.
2.5. All right.
This is a fun story about my oldest boy, Sebastian. He wanted a popsicle for breakfast. And I was like, no, popsicles are a treat, special occasions. It's not, we don't have those for breakfast. It's not food. And he went and he got the cereal box. And he was pretend reading the back of the cereal box.
Uh-huh.
He says, look, Papa, popsicles are food. Popsicles, breakfast. And I was like, oh, that was good.
That was good. But you still don't get a popsicle.
No, he got one. Well, he backed it up with evidence. I wanted to support that part of it. That he had brought text evidence. He might have been 3.
He might have been just a little bit more advanced. I have one more quick study here related to winter colds. And why do we get so many colds in the wintertime? Well, we've talked... Whoa, go ahead. What were you going to say?
Can I guess?
You guess. Guess away.
So the thing I've always heard is it has nothing to do with temperature, but it has to do with the fact that, well, sort of, because it's cold outside, so people are indoors more, and if you're in closer proximity to in a sealed air environment, then sicknesses transmit quick. Colds transmit faster that way. That's what I've always heard.
And this is one aspect of it, but a new study that was published out of Northeastern University this last week by Professor Mansour Amiji. He has been looking at samples from inside people's noses. He took, tissue samples from inside people's noses, and they investigated the role of the nasal epithelium-derived extracellular vesicles in their antiviral immunity responses. And so there's this, when you're in normal temperatures at body temperatures, your nose is like, I'm happy, I'm at a body temperature, 98.6-ish degrees, it's all good, a virus comes in, or some kind of thing, and then your nasal mucosa is like, bleh, spit it out. And then there are these extracellular vesicles that get flushed out of the cells, extracellular, outside of the cell. They get out, and they have these receptors that are antiviral. They attach to the viruses. They end up fighting them off. So they took a lot of specimens from people's noses and then looked at them at room temperature or at body temperature, 37 degrees Celsius, 98.6 degrees Fahrenheit, versus 32 degrees Celsius, which is just like in the 86-ish, 89-ish degree range. Yeah. So not a lot colder, really, but just, the cold air gets in there. It might have cooled down the nose just a little bit during the winter. And they determined that there were fewer of these extracellular vesicles that were elicited to suppress viral infections. They used fairly common RSV. We're dealing with now respiratory syncytial virus and other flu virus kinds of viruses to see. And so what they are considering is that this is a mechanistic explanation for how more colds happen during the winter months. So it's
And
not
so-
just that. It's your nose the inside of the nose gets cold, and so the vesicles are like, the cells are like, not gonna produce the stuff, and they don't. Yeah.
Seems like a very complicated answer. I like Kevin Reardon in the chat room's answer best. It's due to childcare.
Yeah, put kids in a room together, they catch each other things, and then they bring them home, and then you're sick. It's
And
all.
then so does everybody else
That's the
in
way it works.
society. And
Yeah.
Kevin says, welcome to the collective. Yes.
Well,
Beautiful. No, that's a great point. That's a great point. All of the speculation might just have to do with daycare, or like kindergarten. Kids who lick playground equipment, sharing germs together, spreading it to the rest of the world.
What I find interesting about this, though, is that these researchers are, looking at mechanistic therapeutic solutions to this problem. Like, can we create some kind of therapeutic medication or a substance or something that you can use? And I'm just thinking to myself as I'm going by, well, hey, if you wear a mask, your nose is going to be warmer. So, I don't know. Just saying.
Can you imagine, like, you go ahead into the mall on a cold day, and you get, just before you walk in the mall, what are you doing? Oh, I'm just getting ready to go, and start rubbing your nose real hard. It's all nice and red. And you're like, okay, yeah, now I'm ready.
Yeah, you put your hands over your mouth and your nose.
You got some little
Breathe out a little bit
nose,
there.
like earmuffs, but going on the side of your nose to keep them warm.
Oh no,
Little
one of
tiny
those
ones.
pocket hot packs, that you break them and they get warm, but you just stick it over your nose to keep your nose warm. I'm never gonna get sick. Look, we've already solved it. Okay. This is This Week in Science. Thank you so much for joining us for another episode of fun-filled science discussion. If you are enjoying the show, please consider telling a friend, and do make sure to head over to TWIS.org and get one of our 2023 Blair's Animal Corner TWIS calendars. They are gorgeous, beautiful Lego animals artwork that Blair created specifically for this calendar, and we are just so excited that you might be interested in them. Make great gifts. Digital downloads or printed versions are available. And if you go to the Zazzle store, which is where the printed versions are, we have lots of other things too that make great gifts for you or others. Whatever it is. Okay, we're going to move forward now, but it's not Blair's Animal Corner time.
No,
There's
a new segment called Just Interesting Animal Corridor
with
with Justin.
With not
not
Blair. I was going to play the music, but I can't play the music right now.
That's
This is This Week in
fine.
Science. Okay, we're back. Let's talk about the animals. Justin, what you got?
Just Interesting Animals with Justin. Tel Aviv University studies discovered that the female locust has superpowers. Turns out, female locust's central nervous system has elastic properties, allowing her to stretch up to 2 or even 3 times her original length. That's pretty incredible. Lady locusts engage in this super locust behavior while laying eggs in the ground. All that stretching happens without causing any irreparable damage. It was surprising to find this, according to researchers. This is the only creature that they are aware of that can do this. For instance, nerves in the human nervous system can stretch about 30%. It's pretty good. 30% without tearing or becoming permanently damaged. So 200 to 300% is insane by comparison. They think that in the future, these findings may contribute to new developments in the field of regenerative medicine as a basis for nerve restoration, development of synthetic tissues, and of course, one day to make a super stretchy superhero human hybrid creature.
Ooh, like really like an Elastic Man. Super stretchy.
Yeah.
Ooh.
Yeah, you could. You really could. There's a graphic of this too, where her lady locust's abdomen section is stretching down into a hole. They've got these little tubular things at the end of the abdomen that dig out these deep trenches. And so when the abdomen pushes down to the ground, it gets to a certain depth, and it says, okay, now it's cool to lay eggs. We're down far enough, we've safely protected. And then it goes back into shape. And Lady Locust continues on her day like nothing happened.
This sounds like one of those, awesome things that happens to pregnant women. Like there are all sorts of changes that happen to the female mammalian body, but this is, an insect female that's sexually mature. I'm wondering, okay, number one, why does it have to elongate? Is it part of the process of getting the eggs into the ground? Is that like a necessary aspect of it? Is it they elongate and then as they're squishing back up, it just squishes all the eggs out? What's happening with this locust and why? And then how much longer after they do this do they live?
You want a full longevity
Right,
study.
don't locusts die? They're like, I reproduced, so now I'm gonna die.
Everything does eventually.
That's true.
But I guess this is according to the graphic you had up there, it looks like it's about a half-hour process. So it's not like a rapid like bloop bloop kind of a situation. It's a slow elongation, and the researchers are saying they expected there was a hypothesis previously, some other examples in nature that they're familiar with of some form of an accordion-like mechanism, a segmented section of sort of like, what do you call it, Russian dolls, where you've got, one thing is inside another. None of that. They discovered that the nervous system of the female locust has elastic properties.
That's cool.
That allow it to elongate. So it's a very cool thing, but it's also a mechanism they haven't seen before. I love this quote. This is Dr. Panchasik, who is the lead researcher on this. This finding is almost incomprehensible from a biomechanical and morphological point of view. It shows you how sort of like unexpected of a find this was.
But it's definitely related to sexual maturity. So there are hormones involved. There's something going on that changes the capacity of these locusts to be able to become more elastic. Yeah. Making interesting, what is it, quinceañera, or, the various ceremonies that we have for coming of age. And now you are elastic. We will stretch you and you will be fine.
Yeah, isn't that pretty close to home? In fact,
I don't know. But maybe we should be talking to the animals a little bit more. Animals.
Have you got talking animals?
Well, animals talk all the time. It's just whether or not we actually understand them. If you were to sit down and listen to a bunch of animal sounds, horses, sheep, cows, do you think that you would understand what these animals were feeling? The emotion that was being conveyed?
Interesting. So I feel like with the cows and horses, I might have an inkling of their mood. Like sheep and goats, they're just always sound annoyed. So you can't tell. Right. Like they're just like, I don't know if you're happy, sad, or really mad. It all sounds the same to me. But a horse and a cow, they kind of have different emotive qualities to the moos and the nays. Okay, but this is a farm kid, telling you.
Right. Okay, so you're a farm kid, right? So these researchers publishing in the Royal Society this week, they were studying how whether people understand or can kind of understand the emotional aspects. So they were looking at the aspects of emotional arousal, which is like bodily activation related to emotion. Valence is whether or not something is negative or positive, and whether or not we could, by listening to the calls of these animals under various situations of stress or just being on the field and being happy or whatever, whether we could get the emotion or whether we could understand the valence, whether or not it was positive or negative. They also did a bunch of, had participants listen to a bunch of recordings of kind of meaningless word speech, random kind of blah, 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 blah kind of stuff that had different emotional or valent connotations to it in the way that it sounded. So the interesting aspect of this is that the people who were in the studies listening to the animals, they were able to rate above chance the arousal levels of vocalizations of three of the 6 ungulate species that were involved, valence of 4 of them. They didn't differ a lot across arousal levels, and there was a lot of variation on whether or not it was negative or positive sounds. The researchers go on to say that they think that this indicates that there is a shared mammalian system for expressing and understanding emotions, and that we are tuned into that. So what I find interesting, they've got an image in their paper that they published where they've got the correct recognition related to the emotional aspect or the valence aspect, and people seem really, really in tune with horses and with pigs and with goats. We're doing really great there. Not
Goats?
so much. Not
People
as
can
much.
understand a goat. That's fascinating.
Yeah. And then when it comes to correct recognition of valence, people we're really, really close to horses. Like, we're really good at understanding horses, which I find very interesting. Not so good at understanding cows. We don't do the cows so much. But the whole issue here is that domesticated animals, those that we work with often, we are more in tune with. Those that are wild, like a wild boar, as opposed to just a commercial pig, we are not as much in tune with. However, it seemed that we were very in tune with the valence of the wild boars, which would make sense if you didn't want to be attacked by an angry wild boar.
Yeah.
Right?
Yeah.
So it's an interesting study considering cross-species communication and what humans understand, whether we understand.
I thought that was fascinating, that graph, because the people looked like more in tune with understanding goats than they were cows.
Yes.
Now, cow's an open book. To me, cow just tells you how their day's going.
Right.
And a goat is just just sounds like that's, they've got one
I'm with you on the goats thing
all the time. Unless they're like, what was the mood of the goat? Annoyed. Oh yeah, that's what everybody guessed. Oh,
always.
Well then.
Goats are always just annoyed.
Just annoyed.
Yes. Yeah. So anyway, mammals. Do we share an emotional system? Probably. Because it probably helps us out a little bit. Again, this is This Week in Science. If you are enjoying the show, please head over to twist.org. Click on the Patreon link if you're interested in supporting our show as an ongoing Patreon patron. Sponsor, join our Patreon community, $10 or more a month, and we will thank you by name at the end of the show. There's lots of other stuff that comes in the mail if you become a patron, as well as you can become part of our Discord community. And also, while you're at twist.org, please consider heading over and clicking on the 2023 calendar purchasing in print or PDF download. Justin, tell me some stories.
Okay. This is, for those, occasionally, if you're a long-time listener, you've heard me making light of archaeologists' inclination to ascribe ritual or spiritual significance to any ancient artifact that they can't explain otherwise. As though folks of the ancient world were somehow obsessed with nothing more than a zealot's appreciation of whatever beliefs they might have had. This has taken a lot of time. And you wouldn't be entirely wrong in thinking that ritual and spiritual concerns existed. It's just improbable or even impractical to imagine ancient man being so dedicated to a spiritual being in every facet of their material existence that almost every artifact of any type is given this ritual or spiritual significance.
Yeah.
Take the case of the engraved owls. These small owl idols carved into bone or wood. Around 4,000 of them have been discovered across the Iberian Peninsula to around 5,000 years ago. Many have been found in tombs, leading past archaeologists to ascribe ritualistic meanings to the offerings. They might represent lost deities or spiritual protectors of the dead. You know, there's a good argument that because some owls are nocturnal, that the owl's ability to hunt at night gives them the power to see in darkness, imbibes them with some sort of wisdom or perception beyond normal human existence. Or, as is published in scientific reports, the re-examined interpretation suggests these owl plaques may have been children's toys.
Oh, they look
Toys
so
are
like stuffed animal-y. Not at all. They look like carved rocks.
Yeah, it's going to be rock, bone, wood, whatever they could find. So it's an interesting thing that toys are often missing from the archaeological record. Almost as if the concept of child's play was non-existent in the ancient world. Like a child playing with things hadn't been invented yet. And you can't blame the ancient parents with all the rules and cultural and spiritual activities archaeologists imagined them to be involved in. On top of the constant hunting and gathering, there was likely no time to craft children's toys. And that might be so. Researchers provide evidence to suggest that the thousands of owl dolls discovered were likely made by children. The authors assessed 100 plaques and rated them based on how many of the 6 owl traits they displayed, including 2 eyes, feathery tufts, patterned feathers, a flat facial disc, a beak, and wings. The authors compared these to 100 modern images of owls drawn by children aged 4 to 13 and observed many similarities between the depictions of owls. Owl drawings more closely resembled owls as children aged and became more skillful at the craft of representing them. Authors point out that the presence of 2 small holes at the top of many plaques was previously thought to be for stringing them to a cord through them to be worn, right? For the impractical purpose of wearing an owl medallion. Yeah. Instead, they say there's no wear signs that would associate with that specifically. Instead, they speculate that those holes were there to insert feathers. Because local owl species have those sort of feathery tufts on top of their heads. Yeah. And so it looks much more likely that these placements were used to better represent or resemble the tufts on the heads of some of the regional owl species. They're correct. The newly discovered mass prevalence of children's toys in the region I don't know, maybe give archaeologists pause next time they find a little rattle made of bone for honoring the dead, or a small carving out of an animal deity, and ask, would a child play with this? And if so, that might be reason enough for it to exist.
I could see that happening, yeah. Kids like toys. We probably
kids like toys? Are you kidding me? I got a 10-month-old right now who has more personal possessions than I do. He's already got more toys than I have things on the planet.
That seems about right. Yep.
Yeah. And like that was, how has that not been the same since the ancient times? I don't know. Oh, and then the last story tonight. Oh, look at those cute little owl drawings.
Look at those cute little owl drawings.
My last story of the night is I brought just good news.
Yay!
The news segment that dares to look under the college couch cushions of current academic research in search of positive news, loose change, and the occasional unexpected surprise. Just good news, Chardonnay edition. Yeah. Archaeological assessments of soil and climate in the UK have discovered that around 1/5 to even a quarter of the UK is suitable to grow Chardonnay grapes for high-quality winemaking. Alex Biss, a PhD student who led the study, said, there are some great sparkling wines produced from Chardonnay grapes already in the UK. That's with the bubbles. But the grapes used in sparkling wines don't need as much ripening as for still wines. That's the ones without the bubbles. A good Chardonnay vintage is not attained reliably in Britain at present, but climate change looks to change that in the not too distant future. Thanks to global warming, ideal conditions will be reached around mid-century. The research model considered 3 aspects of weather that affect quality of Chardonnay. The mean temperature between April and September, mean minimum temperature in September, the cool at night index, total rainfall between June and September, and the model identified 20 to 25% of UK land may be suitable by 2050 for growing Chardonnay grapes. Now, there's
good news in the future. It's just different places are gonna make the wine. Yes,
20 to 25%. This is up from the current global warming assisted situation of 2%. So that's quite an improvement.
Yeah.
Quoting Biss without attempting an English accent, but maybe drifting a bit mid-Atlantic. We are not celebrating global warming, which for so many is already causing major challenges to food production, public health, and more. Rather, it's something we can monitor and respond to by changing what we grow and where. They used an intermediate greenhouse gas emission scenario in which climate policies can limit global temperature rise to between 2 and 3 degrees Celsius by 2100. I'm glad they're using that. That's a very much more realistic model than sticking. There's too many, if the IPCC, if we the 1.5, if we, forget it. This is better, 2 to 3. Under this scenario, emissions continue to rise till 2040, and then begin to level off. So, just good news for UK viticulturists. It'll be fun to see what other neat surprises global warming brings us in the not too distant future.
Well, on the other side of it, maybe some bad news for France, because that means
Hey! Everybody's gonna have a different silver lining. This is just good news.
There we go. Just good news.
Don't bring us down.
All right, I won't bring us down, but I will.
Keep the blinders on, Kiki.
No. Maybe I'll just keep my VR headset. No. I will implant a Neuralink thing into my head. No, maybe I won't after all.
What is this Neuralink? Yeah, you teased the story at the beginning. What is this?
Yeah, so Neuralink is another company run by Elon Musk. We have discussed it before. It's a medical device company that is developing a brain implant that what they say the hope is that it will help paralyzed people walk and cure neurological ailments. However, Musk's previous statements have been to the effect that we need to be able to basically integrate ourselves with computers, because if we can't become AI will destroy us. So, whatever.
Somebody forgot how to be a human being.
Yeah, well, this company is under a federal probe by the U.S. Department of Agriculture's Inspector General at the request of a federal prosecutor, and it is focusing on violations of the Animal Welfare Act. Researchers within the company, under whistleblower status and anonymity and others, there are documents and interviews with current and former employees that Reuters has in their possession that Musk has been pushing the company in the same way he pushes all his companies. And so as a result, corners are being cut, and the way that animal surgeries and testing is being done is unfortunately leading to the death of more animals than would likely be necessary if the research were done at a slower pace with care taken to be sure that things like the right size implant were being put into the animal, or that they had done not in vivo studies prior to work out the kinks of a device before putting it into an animal. The animals they use are rats, mice, pigs, and also primates. But the issue here is what we're looking at is a private company and how the company is using animals for research. There's no regulations on how many animals companies can use for research. And there is leeway to scientists to determine when and how to use animals in experiments. Neuralink has passed all of the USDA inspections of the facility, so these reports are coming out of the company itself from people who are working in the company and are concerned about the way that the work is being done. Yes. So Musk has said that we're going to get to human trials of Neuralink very soon, and he wants to get to human trials within the next 6 months. But because of that schedule and the stress that everyone is under, employees are concerned that there are hack jobs, quote unquote, being done, last minute changes before surgeries, things being shortchanged in order to meet deadlines that increase risk to animals. And, this is something that I'm glad that the federal government is investigating, because this is important. We don't want devices tested in humans that haven't necessarily passed all the bars, have, gone through studies that have been pushed too quickly. So I think this is one of those interesting middle places between, venture capital, startup culture, and scientific research, and, how it all works. But, yeah, I think, there are animals involved, and there are ethical issues at play here, and I don't know. It's an interesting point, and I want everyone to know that this story is out there, and then that there are questions about the quality of resulting data from the work that is being done within the company.
A few months ago, I might have heard that story and thought, yeah, well, you know what? Hey, make all of the mistakes. Go ahead and push it. See what happens when you put the wrong size thing in it. Do all of that in the animal version.
Right.
So that if you ever get to that point where you're going to put this in a human being, you've looked at a lot of things and record it all and pay attention to it all.
Yes.
And some people are uncomfortable with working with animals, and any number seems to be too great for them.
Absolutely.
I could have alibied all of that. But then I've seen now the Mr. What do you say his name is? Mr. Musk? Is that the fella? The ridiculous messages he was sending to the Twitter employees about needing to work ridiculous hours and dedicate their existence to the company's thing. And if you don't like it, take a hike or do it. And they're firing the guy that made the passcodes, the security guy at the building, and then had to call him up and rehire him because nobody could get into the building. Before that, I would have had confidence well, Mr. Musk seems to know what he's doing. He's got the rocket company.
He's got the rockets. He's got
and
cars,
that boring company is still drilling its way to the core of the earth, I believe. So there's still something. Tesla's
not working much anymore.
Tesla's a great car company. Guy must know what he's doing. So I doubt that he's putting any undue pressure on people. And then now there's evidence that says, this as a CEO, he can act rather erratically and recklessly, and so I now have so much more confidence in those whistleblowers than I would without the CEO's current previous actions.
Right. One interesting connection to all this is that previously, because of the location in California, the University of California, Davis does have a primate center. So Neuralink was involved in a partnership with the University of California, Davis to conduct its experiments. But there was a complaint there of surgeries that killed monkeys. And so the veterinary staff said that there were health problems caused by experiments. This was from UC Davis. And the UC Davis spokesperson said that it defended its research with Neuralink and said that it followed all laws and regulations. But Neuralink has since taken all research in-house. It is not partnering with anybody else anymore. Elon has created a monkey Disneyland. And they are, I don't know, it's a, how do you push forward quickly? It's not rockets. These are living beings. It's a very different, how do you iterate and how do you do the work at the fast pace that financial progress often requires, and still do it ethically and still do it well. So there are, there are a lot of questions here. And I'm glad, once again, I said that the government is looking into it because government regulation of this kind of animal research is very important.
And that's a couple last notes. If I was in that position of this invention and this thing, I would want that proof of concept done out of the company. And I know you're like, we don't want to share information.
Right? Yes.
But
no bias.
There'd be such a risk of everybody who's involved in the research's paycheck relying on getting a specific result. Yep. Then you could end up with a false toddler effect of people saying that we all looked in the box. Everybody looked. Of course we did. Why wouldn't we? It's our job to look in the box. That's what we did, even though they haven't looked in the box. And then you end up with all this investment and it does nothing. On the other hand, I have a feeling that there's a secret Musk fella island somewhere where this is already being done on humans.
It's possible.
Some sort of international waters island. So they're going to figure it out one way or the other.
They'll figure it out one way or the other, but this is where it is right now, and I think we've made it to the end of the show.
Oh, are we there?
Yeah, I think we've done it. We have come to the end, the part of the show where we love to say thank you to everyone who has spent your time with us so far, who has joined us for the last bit of time. And I would love to thank you all for joining us. Thank you everyone in the chat rooms who has chatted and made your comments and asked your questions. Thank you for being here with us. Those of you who are viewing live, those of you who are viewing us later, thank you for being here. Thank you to those of you who helped make this show happen. Fada, thank you so much for helping with show notes and social media. Identity4, thank you for recording the show. And Arnlor and Gord, thank you for helping to keep our chat rooms nice, happy places to be in. And Rachel, thank you so much for editing the show. And I would love to thank our Patreon sponsors. Teresa Smith, James Shaford, Richard Badge, Kent Northcote, Rick Loveman, Pierre Velazar, John Ratnaswamy, Carl Kornfeld, Karen Tozzi, Chris Wozniak, Dave Bunn, Vegard Shefstad, Hal Snyder, Donathan Stiles, a.k.a. Don Stylo, Ali Coffin, Gaurav Sharma, Ragan, Derek Schmidt, Don Mundus, Stephen Albaran, Daryl Myshak, Stu Pollock, Andrew Swanson, Fredus104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles Jack, Brian Carrington, David E. Youngblood, Gru and Bob, John McKee, Greg Riley, Mark Hessenflow, Steve Leisman, a.k.a. Zima, Ken Hayes, Christopher Rappin, Dana Pearson, Richard, Brendan Minish, Johnny Gridley, Remy Day, Flying Out, Christopher Dreyer, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Rick Ramus, Philip Shane, Kurt Larson, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Adam Mishkon, Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul Disney, David Silverly, Patrick Pecoraro, Tony Steele, and Jason Roberts. Thank you for all of your support on Patreon. And if you would like to support us on Patreon, head on over to twist.org and click on that Patreon link. On next week's show,
we'll be back Wednesday, 8 p.m. Pacific time, and again 10 a.m. Thursday, European time. Broadcasting live from our YouTube and Facebook channels. Oh, yeah. Think about it that way.
It's all the same time.
Broadcasting live from our Facebook and from twist.org/live.
Oh, yeah. Want to listen to us as a podcast? Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, get your friends to subscribe too.
For more information on anything you've heard here today, show notes, links to stories are available on our website, www.twist.org, and you can also sign up for our newsletter.
Woohoo! Someday we'll do one. And you can contact us directly. Email me, Kirsten, at kirsten@thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twist.org. Just put twist in the subject line so your email doesn't get spam filtered into a future bottle of Chardonnay that I'm just gonna drink and not read the subject line of.
And if you want to get a chance to be an experiment on Musk Island, you can hit us up on the Twitter, where we are at Twist Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes during the night, please let us know.
We'll be back here next week, and we hope that you will join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.